Hi everyone. This presentation explores how information systems support business processes concerning the development of a bike sharing system. This is the agenda for this presentation. Considering the context between the Healthy Lifestyle Advocacy Group and the IS Developer Company, the project requirement is to develop a bike sharing information system within a medium-sized metropolitan area. Given the overall task, resources, and business processes, the project will be complete by July 30th, 2023, per the project management timeline I've created, which will be discussed further in this presentation. To support and define the scope of this project, as well as to introduce effective communication within the project lifecycle, I've decided to implement a hybrid methodology/framework combining elements from the traditional waterfall methodology and the agile dynamic systems development method. Using an agile approach allows the development teams to test the software iteratively during the implementation phase and supports better project organization. Using a traditional approach ensures proper planning of the business processes and objectives. To set up the discussion in this presentation, in our course readings, Bourgeois suggests that a business process is a strategy for achieving business goals and competitive advantage through a set of business steps by an information system or by people. Therefore, the business processes for this bike sharing system include bike renting, user management, and billing. For this project, the organization will implement a distributed system architecture. This architecture type fits into the IS design since the docking stations and bikes will be located throughout the metropolitan area. Geeks for Geeks suggests that a distributed system is a collection of computer programs that utilize computational resources across multiple separate computational nodes to achieve a common shared goal. The nodes at the docking stations will include separate hardware over the same network, which prevents single point of failure vulnerabilities. Characteristics of distributed architecture include simultaneous processing, which means that several systems can function simultaneously. Failures are easily detected through error detection. The nodes can communicate with each other since they are interconnected, and the computing and processing capabilities can contribute to system and network scalability. Considering the business processes, bike renting, user management, and billing, the hardware will include the physical docking stations and respective locks, the kiosks and the respective servers, the bikes, the network infrastructure to include routers, modems, wires, cables, and switches, etc., the client systems to include PCs and smartphones, and the GPS trackers built into each bike. The software will include storage, the operating systems, Apple iOS and Google Android, mobile application software, the enterprise resource planning system, which handles everything from finances and accounting to project management, human resources and inventory management, and the customer relationship management system, which handles customer satisfaction and customer outreach and advertising. Considering costs and resources, the company will primarily rely on early-stage investors and bank loans. Figure 1 illustrates the architecture and the data flow. For the bike renting process, a customer will access the bike sharing system via PC or mobile device over the internet with its associated OS and unlock and lock the bike at the docking station via the kiosk. At the kiosk, the system will confirm whether the customer has a current annual or day pass subscription, track the user in the bike inventory, and charge customers for their usage. For the user management process, the customer will input his personal and financial information into the application, which will then contact the server and store the customer's information as data in the relational database for safekeeping. For the billing business process, the customer uses the application, which interacts with the ERP system within the software before and after pickup and drop-off. The ERP system is interconnected between the server, the relational database, and the kiosk, verifying information and subscription statuses, calculating ride prices, storing and retrieving data, and ensuring that the customer is charged correctly. Consistent with the interconnected docking stations and nodes operability within the distributed system architecture, the bike sharing system's security framework is applied holistically to ensure secure networks at every station. Given increasing threats as well as changing cybersecurity policies and regulations at the national, regional, and international levels, a structured approach to cybersecurity will ensure the company retains its competitive advantage, compliance, and secures its data. For the bike sharing system, the company will consider the CIA triad within its security framework and recommend awareness campaigns. Confidentiality can be described as ensuring specific people have access to specific information and systems. Awareness campaigns applied to this bike sharing system include IT asset management, so keeping an accurate inventory of the bikes and docking station equipment, data classification, which is ensuring sensitive information is encrypted or protected per cybersecurity policies, enforcing access controls, which means implementing strong password policies within the application to include multi-factor authentication and proactive security measures, so supplying employees and customers with the right information to safeguard sensitive information. Integrity means that the data and information should not be changed unless specifically intended. Awareness campaigns include intrusion detection and prevention, which is implementing IPS and IDS within the system firewalls to monitor network traffic to prevent vulnerabilities, Vulnerability management, which is identifying vulnerabilities, installing patches, and keeping a record of system logs and usage. And reporting measures, so ensuring that employees and customers know when and how to report suspicious behavior. Availability means always having access to information or a particular system, and awareness campaigns include a security incident response plan. So if a cyber attack occurs, this plan includes steps the company can take to restore access, as well as inform authorities and all affected parties. Continuous monitoring, which prevents operational outages and tracks system performance for the distributed nodes and bikes, and backup systems, including backup servers, backup power supplies, and strategies within the incident response plan to ensure availability. Regarding cybersecurity vulnerabilities with the bike sharing system on a global scale, McKinsey suggests 3 trends: on-demand access to ubiquitous data, hackers' use of advanced technology such as AI and machine learning, and the lack of cybersecurity talent in keeping pace with changing requirements. Considering the first trend in relation to the bike sharing system, vulnerabilities include unauthorized access to customer and employee credentials, ERP systems data, and sensitive company information. In response to these vulnerabilities, McKinsey recommends zero trust architecture to separate sensitive company information from clients, which is implemented into the bike sharing system, since user devices are geographically separated from the docking stations and respective servers when bikes are checked out or when customers purchase subscriptions from remote locations. For the second trend, hackers can use ML technology to send out automated phishing emails or ransomware attacks on weak systems. In response, the company must adapt and scale up ML capabilities to automate detection and prevention software to deter potential attackers. For the third trend, companies struggle to keep up with cybersecurity and IT advancements. In response, an option includes integrating cloud computing support, such as software as a service, which can handle security patching, automation, and scalable services. To conceptualize and present the data structures for registration and billing, I created this data dictionary. A data dictionary connects objects, elements, and variables together to create relationships across a relational database. As you can see, the user ID and station ID are both examples of primary and foreign keys. A primary key is used to identify a unique column, while a foreign key is a primary key in a different database table that provides the link between 2 tables. A significant change that I made was changing the data type for most columns from integers to strings because I expect the system to handle more than a set number of users or ride numbers. As we learned previously, you can always convert a string to an integer for calculation purposes. Subsequently, Figure 3 illustrates 3 tables, one that describes registered users, one that describes the docking stations, and one to record information about the rides between the users and the docking stations. These tables are used to describe current and historical rides, which can be found in the SQL database. Figure 4 illustrates the relationship between the tables. Considering the relationship between the registered user table and the rides table, the connecting line and symbols show that a user can have 0 or many ride instances and ride durations, while a ride instance and ride duration must be associated with at least 1 or many users. Looking at the relationship between the docking station table and the rides table, the connecting line and symbols show that a station can have 0 bikes out or many bikes out. However, the bikes must have an association with at least 1 docking station or many docking stations. Figure 5 illustrates the process to calculate the price of a single ride session, factoring in details such as subscription status, bike usage, days subscribed, etc. The software development team will iteratively test this process until the business process is satisfactory. Figure 6 is the project management timeline for the development of this bike sharing system. As you can see, the tasks are characterized by task number and subtasks where applicable, task name, task duration, start and end dates, and an illustrated project timeline. Significant items to note include subtasks 2C through 2E. The team will conduct site surveys looking for high traffic areas for installation. Then the team will secure project funding primarily through early stage investors and if necessary bank loans. And finally, the team will coordinate the installation of equipment provided by the IS developer company. Other subtasks to note include 4A.2 and 4A.3. I've allotted 3 days for iterative software development testing and 3 days for implementing cybersecurity protocols. Prior to launch, the team will meet with business stakeholders to ensure that all business processes are taken care of, and then post-project, the company will focus on collecting feedback and continue to push software updates to improve the system. In conclusion, considering all the details gathered to include evaluating the business processes, system architecture, and system security requirements, I think that the development of this bike sharing system will be a success and that the company will achieve a competitive advantage in the transportation and healthy lifestyle advocacy markets respectively. I appreciate your time, and I look forward to your responses. Thank you.